last time we were discussing about EMAS in general, and also what are the advantages of EMAS, the general advantages, and also we will be seeing how we can make further use of it, and what are the various kinds of skills that we need to enable EMAS. So today we will take this further and see that how we can go into it and then achieve EMAS at a larger scale, and also maybe it will give you an idea of what kind of technologies are actually required to make EMAS a successful technology. So what we'll do is today we will have a look into what are the various stakeholders that we have in EMAS. Okay, so one of the this gives a tentative list, so it's by no means the exhaustive list, but it's a list which gives us an idea of who are the major stakeholders. So first one would be the transportation service provider. We call it as TSP, a short form. Then we have the vehicle fleet operator, so VFOs. So they can be vehicle fleet operators for buses, maybe taxi aggregators, and so on. So these are all fleet operators. Then we have the bus stop operators, or we call it as BSOs, or they can be stop operators, because if we include the metro rail into it, then even the metro stations are a part of the stop. So you can even generalize it and call them as stop operators. Then we have the charging depot operators, because we do focus on e-mobility, and we hope that in near future the bulk of the transportation would be electrified. So we would have the charging depot operator. Then we have something which is known as the record keeper, and we call it as RK. Now record keeper is someone who will keep the record of all the transactions being made, all the data that is generated by the system would be stored by the record keeper, and all kinds of information about the journey, the traffic conditions, and so on goes to the record keeper. Then we the grid operator, because it's all going to be electrified in near future, so grid operator is a major player. And then we have the EMAS user, okay, the last one. So they would be the passengers, people like you and I, who would be using the EMAS services. So these are all some of the major stakeholders. Maybe once we start to think deeper, we can find more and more stakeholders, and this list would expand, but this is what tentatively we think would be the major players. And here on the screen that we have is actually a diagram which shows the interpretation or interaction, I'm sorry, interaction between various stakeholders. Okay, so let's consider what actions would be done during the travel. So you will start a trip. Okay, somebody decides that I would like to travel from point A to point B. So that is the beginning of the trip. The idea has come to the mind. Okay, so the user will enter the start and the end destinations, the addresses, okay, and the time at which the person wants to start the journey. So as soon as one enters the start and the end destination and the time of the journey, then there would be this blue layer. Okay, so this blue layer is all the algorithm layer. So the blue rail layer is going to create route options. Okay, so it will say that if you take route one, maybe you will use these and these kinds of vehicles, and you will reach your destination in say 20 minutes, and it would cost you maybe 50 rupees. If you take route two, then these and these kinds of vehicles would be used, and maybe the trip will cost you 75 rupees, but it would take just 15 minutes to reach your destination. So multiple options would come up. Clear? Now once the route options are there, so this layer, which is the algorithm layer which interacts with the user, will eventually send all the data to find out what are the various types of vehicles that would be used, and also various optimization algorithms. So it will give you routes based on the preferences. Maybe you want to travel by vehicles which will take you to the destination in shortest time or at cheapest cost, or by the shortest route, whatever. I mean, there could be multiple optimization goals that we might have. So even that would be done here by the intelligent algorithms, and it will be interacting with various fleet operators and would be asking that who all is available in these times. So the fleet operators algorithm will say that, okay, I am available at 10 o'clock and I can do this part of the journey and so on. And based on all that, the options would be displayed. Okay, and the options will go to the user. Then user can choose one option out of the various scenarios that are generated. Upon choosing, then a ticket would be generated. So one ticket which is valid through the entire journey would be generated, and that all the vehicles which will be involved during the journey will get the information of the ticket. And here also the division of the cost would happen. So for example, the start destination to the end destination is around 30 kilometers. So a person will travel 10 kilometers by, let's say, by taxi, 15 kilometers by, let's say, bus, 5 kilometers by e-rickshaw, and so on and so forth. Okay, so based on the various vehicle types that would be used and the distance that the person would travel, the share of the tariff will be deposited in that fleet operator's account. Okay, so all that will be done automatically. So eventually the user will have just one ticket and does not need to worry about paying throughout the journey to different vehicle types. And all these contracts, okay, so ticket is a contract. It's a contract between the user and the system. Okay, then the payment guarantee is a contract between the fleet operators and the system. Okay, so and the money that you pay, so it will be through a financial gateway. Okay, so that's again a contract between the user and the system. So all those contracts will be recorded, and there would be a track of all that. So this is how the recording of the contracts is done, because later on if there's any dispute of any kind, then all the contracts can be pulled out for a given journey, and the disputes can be solved. So that is the idea of keeping the contracts between various entities of the system. And of course, then there would be the distribution of money to the stakeholders. Okay, so various stakeholders were involved, various types of vehicles were involved. So based on the journey that they do, the time of the day at which they do the journey, and so on, so the money distribution would be done based on the records of the contracts that we have here. So this is a tentative interaction diagram between various stakeholders. So it can, of course, it's very possible that there are more interactions happening. We have to capture them. This is just a slide to give a tentative idea of what all can be involved, and later on all of you can build up upon it. Okay, you can come up with more ideas and enhance it. Now here we try to look into that what kind of interactions would happen once we are doing a journey. Okay, so it's from the user's point of view. So here, for example, if I'm traveling with a taxi, so it will ensure that a travel request is generated and confirmed for each booking. So that's what the middle layer, the blue layer would be doing in the previous slide. Okay, it will generate a manifest for every trip. So manifest is a technical name for a ticket. Okay, so a ticket would be generated for every trip. It will set down the location and the schedule time. Okay, it will take all the details of the customer, clear, who is the person, the age, the start point, the end point, and also would ensure that the payment is done seamlessly. Okay, and we can have a paper based ticket or a paperless ticket. Okay, so that's an option. We should have both the options, because the older generation will not be comfortable with a paperless ticket option, but the younger generation would be more comfortable with a paperless ticket. So both the options should be there. And also, if we create a very friendly user interface, then we can get even the real-time information of all the vehicles which will be involved in my journey. Okay, so if I have a bus, a taxi, an e-rickshaw, all three involved, even a metro train involved, then I would be having the real status of all the vehicles which I would be taking to fulfill my journey. Okay, and even the system would be tracking me. For example, if there is any delay anywhere, then the system will redo my itinerary and make sure that any kind of traffic delays and so on do not create a disruption in my journey. Okay, and does not increase my wait time. So all those kinds of informations would be displayed real time to me on my user device. But if I don't have a smart device with me, like a smartphone, or a tablet, then of course I can avail such information via phone, because there is still a big chunk of the older generation who would not be comfortable with extensive use of technology, and they would still rely on phone. So even phone based monitoring would be possible. Okay, plus there would be a security layer which would be monitoring the journey of the passenger at every instant of time to make sure that no unwanted incident happens. Okay, that is to check any kind of a criminal activity happening. So even those kind of security provisions that such a system would need. And here, this slide gives you an idea of the amount of data that will be generated. Okay, because it's a huge amount of data, and all the data interact with other data to create a seamless experience. Okay, so now if we need to understand the type of interactions that will happen with the between the data from various sources of origin, then we need to have an idea of who is generating what kind of a data. Okay, so for example, grid, which is a stakeholder, so it will generate data about the grid load status. Okay, and also the payments, because this is an important information for the charging station. Okay, so a charging depot needs to know the grid load status. So for example, if the grid is heavily stressed on a given day, maybe it's a very hot day, and let's say the air conditioning loads are more, and the grid is extremely stressed for next 2 hours or 3 hours, then we will the grid will give the information to the charging depot that, well, right now I won't have excess of energy with me available. Okay, then the charging stations are also aware that they won't be able to service much of the vehicles that would be coming. So this way, data from one point of origin becomes important for the other stakeholder and has an implication on the other some other stakeholder. So this way we can get a clear idea of various kinds of data that is involved. It's not just the data, but also we need to understand that who is creating that data. Okay, and other point which we will also have to understand is that some data will be created faster than the other data. Okay, for example, if you look at the vehicle, so vehicle will create a real time location data which would be changing maybe every minute, every second, or every 5 second or 10 second. Okay, it will create a data about the vehicle maintenance schedule, because we will have an intelligent diagnostics on board every vehicle which will be predicting the kind of failure that the vehicle might expect in near future. So this maintenance schedule data would be generated maybe every half an hour. Okay, so you can see here a vehicle will generate one data which is a real time location, which is almost instantaneous, maybe every second, 2 seconds, or 5 seconds, whereas the failure that the vehicle might expect in some of the subsystems would be generated every half an hour, whereas the grid load status will be changing every 1 hour or half an hour, depending on at what regular intervals the grid operator updates its value. Okay, now payment to the grid, so all the payments will not happen real time. Maybe the payments will happen on a daily basis or on a weekly basis. So every data will have a different rate of generation, a different frequency. Okay, now the algorithm which will be creating or which will be using all this data to create the intelligence in the system has to keep in mind that at what rate a data is being generated by a given stakeholder. Okay, and how to make decisions based on the data coming at different intervals of time. So this is what we can get an idea using the slide which is shown here. Okay, now here also we try to show even more exhaustive set of data from different stakeholders. So, as I told you, there are multiple stakeholders. Like PEU is the EMAS user. Okay, so the user are like are people like you and I. So they will be giving you the data of start and end of journey, start time, mode of travel, payment, journey options. Okay, so and they would be also needing the data of the weather condition, traffic conditions, and so on. Okay, so these are the data which are involved with the user of the system. Then charging depot operator, for example, would need to create data about the charging slots that are available, for what duration they are available. The charging station should know what is the status of the grid. Okay, it should also know if there's a swap happening. It should also know that how many pre-charged batteries should it keep in its repository. Okay, it will also come to know that uh, give in a given duration of time how many vehicles are expected to go to the different charging points. Okay, weather condition is extremely important. Maybe if it's a bad day with a lot of rain and so on, so the swap operation might be slowed down a bit. Okay, so one has to take those into account while planning for the entire day. Okay, so this way we see that various kinds of stakeholders would be creating their own data and will be using the data from the other stakeholder. Okay, so here in this slide we try to understand what is the set of data being created and what is the set of data arriving at a stakeholder from different sources. Okay, so this will give a better picture of how the local algorithms at each of the stakeholder would operate. Okay, so every stakeholder will have its own algorithm to make decisions, and there would be then a global algorithm which will make a decision based on all the decisions made locally. So you see, we will have to build intelligence at multiple levels. So every stakeholder has intelligent algorithms. It makes certain decisions. All these decisions go to a higher level algorithm, where the higher level algorithm makes a decision for the entire system. So that's how we call this as a distributed intelligence, and that's what we will have to develop. And here these are for the other stakeholders. Okay, so maybe once you have the slides, which will be by this weekend, so you can go through the slides and try to understand what all are the interactions that's happening. And I would encourage you that please think deeper and see what is missing and can more things be included. Okay, so that's the idea of the webinar here, is to encourage you to come out with more ideas and innovations in such kind of technology development scenarios. Now, after having said that, we also have to understand the role of various stakeholders. So, for example, if somebody asks a question that what exactly is the role of the transportation service provider? Okay, so the role of the transportation service provider would be, for example, to fix the routes and the schedule, would be to fix the tariff. Okay, it would be to coordinate among various stakeholders like the grid, the charging depot operators, the bus stops, and so on. Okay, the maintenance and classification of vehicles. So this will have the idea that okay, in my entire system I have 200 buses operating, 3,000 taxis, 5,000 auto rickshaws, 8,000 e-rickshaws. So it will have the information about who all or what are the various kinds of vehicles that are operating within the system. Okay, and it will also be it will have situational awareness about timings and delays. So it will have the information that okay, on a certain route there is a traffic congestion, so there is a delay of around 10 minutes on that route, and so on and so forth. So it will be aware of the current situation of the traffic and also of the vehicles. Okay, So maybe some couple of buses are under maintenance, maybe 10 15 taxis are not working today because they have a major breakdown, maybe there are 6 auto rickshaws whose batteries are completely discharged. Okay, so all those kinds of information about the vehicle, the system, the transportation service provider would have. Okay, and it will also make sure that regular announcements about service outages means disruption, okay, route or schedule changes, and new service offerings are made. So this will be the prime responsibility of the transportation service provider to communicate effectively with the end user. And of course, it would be the interface which will receive the payment from the customers and then eventually distribute the payment among the various stakeholders. Now, if we see the role of the record keeper, so the record keeper will have the historical information of all the financial transactions that have happened. Okay, all the travel details of every journey that has taken place. Okay, information about every vehicle, the real time information that how many times the vehicle went for charging during a day, and what are the various kinds of breakdowns the vehicle had, what was the maintenance schedule of the vehicle. So you see, even the record keeper will have the information about every vehicle. For example, car A needs, or taxi A, for example, needs to be maintained every 6 months. Okay, so it will send the information to the vehicle's owner that your maintenance date is coming nearby. You should better take your car for maintenance on this and this day at this and this time interval. Then this will ensure that the interruption to the system is minimum and you will get a service immediately. So all those kinds of information the record keeper will have. Okay, and also will keep the pattern of electricity consumption, the weather patterns, and so on. So based on all this data, eventually some intelligent decisions can be made. Now, for example, if somebody asks that what is the role of the bus stop operator in the entire scenario, then it would be actually to collect information about passengers waiting at the bus stop and give it to the transport system provider. Okay, now this is something unique which people are thinking about. Uh, Depending on how much crowd is available or is present at a given bus stop or number of bus stops, on based on this information, actually the frequency or the timetable of the buses plying on the route can be altered. Okay, so the idea is that we do not have a rigid timetable of the buses, but the availability of the buses will be on demand. If there are a lot of people waiting at many bus stops at a given instant of time, it means the travel demand is higher. So the number of buses operating per hour can be increased. If the number of waiting people waiting at the bus stop is less, that means the travel demand is lower. So we can reduce the frequency of the buses plying on a given route. So this way we can create an adaptive scheduling or an adaptive timetable for the buses, and this will maximize the utilization of the services and will make sure that we don't have overcrowded buses, or nor do we have almost empty buses moving along a given route. So this is the idea. Okay, and also it gives various real-time information that the system generates about outages, delays, weather conditions, so on and so forth, about new services. So all this is the task of, let's say, the bus stop operator. Similarly, the role of the charging depot operators can be to understand the needs of the various vehicles, the charging needs of the various vehicles, keep itself ready. In case of a swap, keep enough batteries ready with it, pre-charged batteries. Okay, continuously interact with the grid. Okay, make power purchase agreements well in advance. Also, make sure that the renewable energy sources are used more to charge the vehicles. Okay, so all that can be the role of the charging depot operator. Similarly, if we see the grid operator, Okay, so the grid operator will have a major role because it has other loads other than the transportation system. Clear? So it will have a good idea of what is the generation scenario from conventional sources and also from renewable sources, what is the weather pattern, and what is the current load demand, uh, what kind of spikes can come in the load demand during the day, plus what would be the additional demand of the transportation system. Okay, the load demand from the transportation system. So all that would be available with the grid operator, and based on that it will make certain decisions, like maybe it needs to buy more energy from the producers. Okay, maybe it needs to negotiate with the charging stations that, well, today maybe between 4 p.m. and 5 p.m. the charging stations should discourage fast charging and should encourage slow or moderate charging because there would be an extensive stress on the system. So this kind of decisions the grid operator would make. And similarly, fleet operator, it's very clear. The fleet operator would know that which type of bus vehicle would be used in a given journey, and what would be the demand for the various kind of vehicles. Maybe from 8 a.m. till 9 a.m. there would be a surge in the demand of taxis. Maybe between 10 a.m. and 11 a.m. there would be a surge in the demand of e-rickshaws and so on. So all those kind of information would be available with the fleet operator and would keep that number of vehicles available at different locations to fulfill the travel requests of various people or the passengers or the users of the system. So this is again the task of the vehicle fleet operator. And here are some of the potential pitfalls, okay, that can happen in Indian scenario. Okay, this is again by no means an exhaustive list. Maybe we will have to think about more and more issues, because every pitfall that we identify is possibly an area of research and development. Okay, so if this list becomes bigger, then we have more and more ideas to make this system robust. Okay, so since such a system does not exist, so it's more of a mental imagination exercise that we have to do, and based on that certain pitfalls are written here. Okay, so one is like there is a serious lack in the country in general in technical capacity involving data analysis. Okay, so which is known as big data analysis. We don't have enough talent pool available in the country. It has to be developed. Okay, if we don't have an enough talent pool on big data analysis and big data problems, then this becomes a bottleneck in developing such a system for India. Okay, then there is a lack of advanced analytic solutions in the public transportation industry. Okay, so public transportation is very much unstructured and fractured in India right now. There are government on bodies, there are many private operators, so it's a mishmash of many things. So it has to be streamlined, a better legislation has to be brought in. Okay, so these are some of the issues. So most of the issues are again related to lack of skills and lack of proper talent pool available right now. Okay, plus there is no precedence or history of managing a user friendly public transportation system. Okay, we do have public transportation system for a long time, but if you see the point number 8, there still is no coordination between different public transportation systems within the city. Okay, so bus can come at any time, it will drop you at a metro station, but it won't be synchronized with the metro train, nor are the metro trains synchronized with the buses. So there is a lack of coordination. Plus there is no evidence of customer friendly or user friendly public transportation system. Okay, so these are all the issues which are potential pitfalls for developing such an intelligent system in India. So apart from technical expertise, we don't have enough management expertise. Plus, we never ever did, as far as I remember, we never ever did any kind of consumer surveys or expectation surveys for public transportation in the country. I don't think so this has ever happened. Okay. So we really don't know that what exactly do people need, what are the troubles that they face with the current system. So all this kind of information and data is missing in the country. So even that has to be created. So if we see, this is a very challenging task to develop such a system. But yes, it does not mean that we should not strive for it. uh, the work has to start, and the work has to start with all of us thinking more into it, coming up with more and more ideas, and then eventually developing technologies to enable it. So this can't happen in one go, that today we decide that, well, we will implement this system and in 5 years we have it. No, that won't happen. We will have to go for organic growth. So step by step the system will be built. Okay. But then there are various aspects which we have to fulfill, and this presentation was an idea to spur a debate among people, that what can be done, what should be done, and how can it be done. Okay.